Hello students, in this video I will be going through some examples with you where we have expressions with imaginary or complex numbers in the denominator and we're asked to simplify. So if you're asked to simplify expressions where in the denominator there are complex numbers or imaginary numbers, what you need to do is we need to, again, rationalize. We need to get rid of the imaginary, we need to get rid of or change a denominator so that it becomes real, so that it becomes not imaginary and not complex. So how are we going to do that? If you recall from earlier on in this course, an imaginary number is a number that looks like this. And rather than writing square root of -1, okay, the shorthand is with I. So what you're really asked to do, okay, the denominator right now, just like in the previous video on rationalizing expressions, okay, what you have in the denominator is actually a radical. So how are we going to get rid of this? Well, if I square both sides, what will happen is the radical -1 will become -1. So I squared is -1. And we've worked with complex numbers before where you had to simplify the expression, okay? Or if you don't recall this, okay, this is a quick refresher on that. If I square I'll end up with -1. If I cube I'll end up with -I. If I raise it to the fourth power, I will end up with +1, right? And then I to the fifth will go back to just I. Anyway, so what we want to do now, okay, is we want to rationalize the denominator. So I want to multiply both the numerator and denominator by 7i, or just I. And if I do, I'll end up with 3i plus 10i squared all over -7i squared. And what exactly is 7i squared? Or what is I squared? That's -1. So the denominator becomes 7. Now it's rational. The numerator, okay, I squared, I have 3i plus 10i squared. Well, that's really -10 plus 3i. Whenever you're writing a complex number, it's always real plus the imaginary in this format, just like I have here, okay? You don't write 3i plus -10 or 3i minus 10. You write the real and then the imaginary. That's the formality, okay? All right, so let's move on. Let's take a look at another one. All right, so I have 8 minus 5i over -10 plus 2i. We're going to need to rationalize this, and just like in the previous video, we're going to multiply by the conjugate. So the conjugate of -10 plus 2i is -10 minus 2i. And if we do just that, the denominator, I'll write it out here. The denominator will end up being something very, very nice, okay? Actually, I won't need that big. You're going to see the questions in this exercise are far simpler than the previous one. So this becomes 10 squared, which is 100, minus 2i quantity squared, right? I'll leave that for now. And then the numerator, okay, we're going to have to actually FOIL this out. 8 minus 5i times -10 minus 2i. So what is that? That becomes -80 minus 16i plus 50i plus 10i squared. And we're going to need to clean up a little bit. This is -80. The -16i and 50i, that becomes 34i. And then plus 10i squared, that becomes minus 10. And then I can further combine things together. This is negative 90 plus 34i. So this is my numerator. And the denominator reduces down to 100 minus negative 4, right? Or it's just 104. So it's this. And just looking at this a little further, right, I noticed that there is a common factor of 2. So this becomes 52. This becomes negative 45 plus 17i. So that's my final answer there. Let's take a look at the next one. I'm going to multiply the numerator and denominator again by the conjugate, and hopefully you guys are getting the idea now. It's 8 minus 9i. And if I do, I'll end up with the denominator is 64 minus 81i squared, right? And what is 81i squared? That's negative 81, or it becomes plus 81. And then the numerator is 10 minus 9i times 8 minus 9i. And if we FOIL this out, this becomes 80 minus 90i minus 72i plus 81i squared. And this can further be reduced. So I get 80 minus 162i minus 81. Or it's negative 1 minus 162i. So this is negative 1 minus 162i. And all of this gets reduced. 64 plus 81. That will be, what is that? 145? Yes. And the numerator is negative 1 minus 162i. And that's the final answer right there.